All right, so let's start with 13.4. All right, scientific notation. All right, so scientific notation is going to be in the form of A plus. Oh, I said plus, it should be times. Let me change that. Should be A times 10 to the nth power. So that's the form of scientific notation, where A is going to be in between 1 and 10, and N is an integer. So it is okay for A to be equal to 1, but it cannot be equal to 10. And N, your exponent, has to be an integer. In other words, it can't be a fraction or a decimal. So examples of that is 1.23 times 10 to the fifth power, or 8.7 times 10 to the negative 11th power. So notice this number that's sitting in front of the multiplication sign is between 1 and 10, both cases. And then your exponents are integers. They can be positive or negative, but they cannot be fractions or decimals. All right. All right, so we're going to write using scientific, I left out in scientific notation. All right, so if I have 53,000 and I want to write it in scientific notation, I need to move my decimal and put it in a place where the number that I have in front of my multiplication sign is in between 1 and 10. So in other words, if I put my decimal right here, that gives me 53. That number, of course, is greater than 10. So I want to put my number, or my decimal, what I should say is right here. That will give me 5.3, which is the number that's in between 1 and 10. So what I'm going to do is find the decimal. And in this case, when you don't see it, they assume you know it's furthest to the rightmost digit. And I'm going to move it however many spaces it takes to create a number that's in between 1 and 10. So I moved it 1, 2, 3, 4 to the left. So that's going to be 5.3. And that'll be times 10 to the fourth power. So I moved it 4 to the right, or 4 to the left, excuse me. So it's going to be 10 to the fourth power. All right, for the next one, do the same thing, but this time I want my decimal to be between the 7 and the 9. That will give me 7.9. Move decimal 1, 2, 3, 4, 5, 6 to the right. So 7.9 times 10 to the negative 6. All right, we had a small number, and we turned it into a large number by taking it into 7.9. So that means our exponent would be negative 6 or negative. Before we had a larger number, and that 10 to whatever power is supposed to represent that larger number. So that's why that's a positive 4. And B, we had a smaller number, that 0.0000079. So that exponent is going to be negative to represent that smaller number that we have. All right. Questions. All right, so here, just doing the same thing, just trying to make sure I gave you enough examples of what's going on and how to do it. Once again, our decimal is right here. If you don't see it, they assume we know it's to the right of the rightmost digit. And we're going 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. So your answer is going to be 1.5 times 10 to the ninth power. And the next one, taking it to the right. 1, 2, 3, 4, 5, 6, 7. So the answer would be 8.571. And we went 7 to the right. So it'd be 10 to the negative 7 power. All right, questions on turning a number into scientific notation. All right, so here we're doing the opposite. We have 1.67 times 10 to the fifth power, and we want to take it to standard form. So we got 1.67, and this positive 5 as an exponent needs to have a positive effect on this 1.67, so I need to make it greater. So we're going to move it to the right, 2, 3, 4, 5. So we're just undoing the process that we just executed. So moving it 5 to the right, use 3 zeros as placeholders. And that'll be your answer. Same thing goes with the next one, except the opposite because we have a negative exponent. So this time we have to have a negative effect or make this number smaller. We're going to take it 3 spots to the left. And that would be that answer. Questions? Any questions? Okay, next thing in this section. All right, 8.7 times 10 to the fourth times 2.5 times 10 to the negative 12th. So the way you should go about calculating, even if you don't write this out, is how you should compartmentalize it. That you're going to multiply 8.7 times the 2.5, then multiply the 10 to the fourth power times the 10 to the negative 12th power. So the 8.7 times 2.5 is 21.75. And don't forget, when we're multiplying like bases, all you do is add your exponents. So that's 10 to the negative 8th. 4 plus negative 12 is negative 8. And don't forget, this number needs to be in between 1 and 10 if you're going to put it in scientific notation. So we want to move this decimal one place to the left. So that would be 2.175 times 10 to the first power. If you're talking about what that will result in is 10 to the first power because we move it one spot to the left. And that 10 to the negative 8 is still there. So now 10.175 is in between 1 and 10, so that fits our definition of scientific notation. And then once again, we can add our exponents to the exponent of the base 10s or 10 base to the piece that have 10 as a base. There you go. So that's 1 plus negative 8, which would be negative 7. So that would be the answer. All right, one more, but questions? Any questions? All right, so here we have 4.25 times 10 to the 13th divided by 8.5 times 10 to the negative second. So once again, we're going to separate our calculations. That's how we should be looking at that. All right, 4.25 divided by 8.5 is 0.5. Here we have 10 to the 13th divided by 10 to the negative second. Don't forget, we're going to subtract our exponents now. And you have 13 minus negative 2. Make sure you don't lose a negative. And that's going to be 15 because a negative to a negative turns positive. That's going to be 10 to the 15th power. All right. So now, once again, we have a scenario in which the number that's sitting right here is not in between 1 and 10. It's actually less than 1. So I need to take that decimal, move it to the right 1. That will give me 5. So that'll be 5 to the negative first power. And that 10 to the 15th is still right there. And now we can add our exponents. Negative 1 plus 15 is 14. All right. Questions, questions, questions. All right. All right, so the next section is adding and subtracting polynomials. Let's see, are they going with terms? Yeah, be all right. So we will do this by what we call like terms. And the only way you can add or subtract your terms, they have to be like or considered like. So that means they have to have the same variables, same amount of variables, same exponent on your variables. So 3x and 5x are like terms. 8x squared, negative 10x squared will be considered like terms. 121x squared y and 70x squared y like terms. And even numbers not having exponent at all or variables at all are still considered like terms. Those are numbers we normally used to dealing with, of course. All right. So if anything's different in the variables or exponents, they are considered unlike, and you cannot add them or subtract them from each other. So if I have 3x and 5, then of course I cannot add them or subtract them from each other. If I have 8x squared, negative 10x, even though both of them have x, one has the power of 2, the other one doesn't, so they cannot be added or subtracted from each other. And even if I have x squared y and the other one just has xy, same type of deal, cannot add them or subtract them from each other. All right. Any questions on that before we try it out? All right, so here we just have just terms, just to make sure we're okay with what we can add and what we cannot add. Same thing flows for subtraction. 5x plus 3x is going to be 8x. They are like terms. 5x plus 3 is already in lowest terms. 5x plus 3y is already in lowest terms. Can I add those together because one has x, the other one has y? 5x squared plus 3x squared would be 8x squared. And then the last one, 5x squared plus 3x, is already in lowest terms. Because one has a power of 2, the other one doesn't. All right, any questions? All right, so we have something like this, 10x minus 2y plus 7x plus 5y. All you're going to do is combine your like terms. And whatever cannot be combined, you just bring it down as a part of your final answer. So 10x plus 7x, 17x, negative 2y and positive 5y. It's going to be a plus 3y. And that's all you would do. All right, so for the next one, negative 3c cubed plus 5c squared minus 7c plus 11c cubed plus 6c squared plus 3. So once again, you combine the terms that are alike and then terms that are not or does not have anything to combine with, you just bring it down as a part of your final answer. So negative 3c cubed and 11c cubed is going to be 8c cubed, 5c squared plus 6c squared, 11c squared. Now this negative 7c, there's nothing I can combine that with, so I just bring it down. Same thing with this plus 3, and that'll be your final answer. All right, so here we have 4w squared minus 2x plus 3w squared minus 4x squared plus 6x. So combine your terms. 4w squared, 3w squared, 7w squared, negative 2x plus 6x, 4x, and then that negative 4x squared, nothing you can do with that but bring it down. Before we get to subtraction, any questions? All right, so subtraction is very similar to addition. It's just that there's one extra step. We have this minus sign that's sitting in front of your, or in between your parentheses or your quantities. Before you combine your like terms, this minus sign needs to be distributed to each term that follows parentheses. In other words, using the opposite term of each. So even if you don't rewrite it, this is how you should be processing what's going on. That turns into a negative 11p squared minus 4p plus 6. So each one of your terms in the first parentheses stay the same. Each one that's in the following parentheses, or the parentheses that follows the subtraction, would be opposite. All right. So from there, you combine your like terms. Negative 4p to the fourth. Oh, nothing I combine that with. So you go ahead and bring that down. 5p squared, negative 11p squared, negative 6p squared. And I have minus 4p, and negative 3 and positive 6. Should be a positive 3. All right, any questions so far? All right, sounds good, sounds good. All right, do one more. I think that was, yeah, we only did one with subtraction. Do one more, and that's pretty much it as far as this section is concerned. Just variations of adding and subtracting polynomials. Of course, if you see anything that you have a question on, make sure you ask. So here, same scenario here, we have a squared minus 2ab plus 7b squared minus negative 8a squared minus 6ab plus 2b squared. Once again, that minus sign needs to be distributed to each term that's in that parentheses. So that'll be a plus 8a squared plus 6ab minus 2b squared. All right, combine your like terms. 8a and a squared will be 9a squared. Negative 2ab, 6ab will be plus 4ab. And then 7b. Oh, let me lose my b. So 7b squared negative 2b squared will be plus 5b squared. That'll be the answer. So what we have left is 13.6, 13.7. Let's try to see. We can go ahead and do 13.6 today. All right, so we talk about multiplying polynomials. Difference between multiplying and adding and subtracting is that, add and subtract, you have to have your like terms. When it comes to multiplication, you do not. So we're going to follow our exponent rules. So multiplying 3 times 4, and just like I said before, even when you don't write it out, this is how you should be processing it. And it's with the hopes that at some point, you wouldn't have to write it all out. Just like with everything, you get used to doing it. You don't have to write down every single step, but most definitely I will because we're on the board. But 3 times 4 will give you 12. And then when you multiply like bases, you add your exponent, so it's x to the 6. 3 times 4 is 12. 4 plus 2 will give you 6. Same thing happens down here. I have negative 5 c to the 5th d times 2 c squared d cubed e. So I multiply the 5, negative 5 times 2, c to the 5th times c squared, d times d cubed, and then e is just sitting on the outside. Nothing I can combine the e with. Finish it off by doing the multiplication. 5 times 2 is negative 10. Add your exponents for c, c to the 7th. Add your exponents for d. Don't forget when you don't see anything, assume you know it's a 1 there. So that's d to the 4th. And then e is on the back of that. All right, questions on that, either one of those two. So you multiply the numbers in front of the variables, your coefficients, they're called coefficients. Then you add your exponents of your like bases. All right, so here we're multiplying what we call a monomial single term times a binomial. We have two terms here. Before we just had a single term times a single term. Terms are split up by your minus and plus signs. So down here you have three terms. But all you would do is distribute, just like you would if you didn't have those variables there. Same principles hold true. So I'm going to write down what's actually happening. But of course, we don't want to have to write down every single step like this every single time. But that 2t times 4t is what's happening in the first term, and then 2t times 3 is what's going on in the second term. So that's the same thing that was happening up in our first examples. 2 times 4 is 8. T times t is t squared. And then 3 times 2 is 6. And leave that t in the back. All right. Next one, we're going to take negative 3a squared, distribute. So negative 3 times negative 4 is a positive 12. A squared times a squared is a to the 4th. Negative 3 times 2 is negative 6. A squared times a to the 1st is a cubed. Now this next one, make sure you don't forget your fraction work. That's 3 times 1/3. 3 is the same thing as 3 over 1, so that's 3 over 3 when you multiply across. And 3 over 3 is just 1. So that's negative times negative, which is positive. So that'll be a 1a squared. That would be your answer. Don't forget 1a is the same thing as a, just like 1b is the same thing as b. 1x is the same thing as x. So you will never see that 1 sitting in front of your variable as a part of your final answer. They will expect you to drop the 1. And when they have just a variable there, they expect you to know that there's a 1 sitting out front. So it's understood. Any questions? All right, c minus 7 times c minus 2. Well, some may remember is the FOIL method, first, outer, inner, last. If nothing else, you can just remember that each term in your first parentheses needs to be distributed to each term in your second parentheses. So c needs to be multiplied to each one of those. So c times c is c squared. C times negative 2 is negative 2c. Same thing here, negative 7 needs to be multiplied to each one of those terms. So that's negative 7c. Negative 7 times negative 2 is a positive 14. So that's c squared minus 9c plus 14. And then say it, I mean, we said it, but just didn't emphasize it. And notice we had like terms in the middle, so you are expected to combine like terms when needed to write the simplest answer possible. That's what this section is about, just different variations of multiplying your polynomials. Like I said, if you can hold true to the idea that whatever's in this first term needs to be distributed to each term in the following, whatever's in this first set of parentheses should be distributed to each term in the following, you'll be all right. So here we have y minus 2 times 3y squared plus y minus 5. So y times 3y squared is 3y cubed. Y times y is y squared. Y times negative 5 is negative 5y. Then we distribute negative 2 to each. So it's negative 6y, it should be negative 6y squared, then negative 2y, then plus 10. All right, questions? Any questions? Combine your like terms. So your 3y cubed can't be combined with anything. Y squared and negative 6y squared, negative 5y squared, negative 5y, negative 2y, negative 7y, and then that's a plus 10 in the back. All right, so here we have special products, like they call it. They like to call it certain things. Certain scenarios, special things occur whenever you have the same terms, except your plus and minus sign are what's different in the middle. What will happen is that when you go to distribute, that'll be x squared plus 9x minus 9x minus 81. What will always occur is that this middle terms will cancel out, leaving you x squared minus 81, giving us a difference of squares. We'll talk more about that, later. But that will always occur whenever you have your two terms being the same except for the signs in the middle. For this next one, 1/2 p plus 6, 1/2 p minus 6. Same thing is going to happen when you do your distribution. Just make sure you hold true to your fraction work. We have 1/2 times 1/2. Multiply across, that's just 1/4. So that's 1/4. P times p is p squared. Next one, we have 1/2 times 6. So that's 6 over 2, which is 3. So it'll be a minus 3p. 6 times 1/2 is the same thing, so that'll be a plus 3p. 6 times negative 6 is negative 36. Negative 3p and positive p3. 3p will cancel, leaving you with 1/4 p squared minus 36. All right, one more scenario and then we'll be done. Questions before we do that? All right, so like I said, last scenario for the day, 3w minus 4 squared. So what we have here is, what we cannot do here is square each term and call it a day. What we actually have to do is recognize that it's the whole quantity that's being squared. We can't square 4 and square 3w. We have to square the whole thing and do our distribution. So that's 3w minus 4 times 3w minus 4. Distribute the 3w. That'd be 9w squared minus 12w minus 12w plus 16. Combine your like terms. 9w squared minus 24w plus 16. All right. Same thing for the last one. 5x squared plus 2 squared is going to be 5x squared plus 2, 5x squared plus 2. Do your distribution and be careful with your exponents. So 5xw, 5x squared times 5x squared is 25x to the fourth. 2 to 2 add up to give you 4. 5x squared times 2 is 10x squared. 2 times 5x squared is going to be 10x squared, and then 2 times 2 is 4 in the back. Like terms, 10x squared plus 10x squared, 25x to the fourth plus 20x squared plus 4. That's our final answer. All right. All right. Questions on anything? Concerns, comments? All right. So, just as a reminder, don't forget our semester ends in November, not December, for those of you who are used to that December end date. Ms. Pentanard.
Hi. Okay, so for 10-week grades, are you counting like as final grades, or you just want us to complete the assignments you already assigned?
We said counting as final grades. You talking about, like, in other words, whatever I put for 10 weeks will be it?
Yeah.
No, no. That's just a gauge as to where you are at this moment. Everything will still be open, so you still be able to bring that grade up by the final grade. Yeah.
Okay, thank you.
Yep, no problem. Glad you asked that. But yep, so just to make sure I clarify for everybody who's listening, whenever, well, I guess it don't matter about 5 weeks now because you guys are not going to take me for 5 weeks. But that 10 weeks grade is just a measurement as to where you are at this moment. Technically, I should be holding you accountable for everything we talked about up to what, 13.6. But I would say, where my sections go, I most definitely would be looking at everything up to chapter 11. You know, if you're talking about, because chapter 13 is in the chapter that we're in right now. So at least everything up to chapter 11. Those are going to be submitted Sunday or Monday. If I can get to them Sunday, as far as 10-week grade are concerned, I'll submit them Sunday. But if not, I'll be submitting them Monday. Um, yep. So, yep. Once again, it's just like a progress report. Not sure how everybody else is doing it, but as far as my class is concerned, you still have the opportunity to bring those grades up. Just got to take advantage of the fact that everything's still open. All right. Any other questions before we close? Good. Straight. All right. Well, you guys have a great weekend. Be safe. And if you have any questions, feel free to let me know. Shoot me an email. Outside of that, I will see you guys on Tuesday. Oh, unless I was just made aware that Tuesday might be a holiday as far as Virginia is concerned. I'm gonna do some research because you know the what is it called? The voting. So if I found out that, then stay close to your emails and I'll let you know. All right, take care.